This is Chemistry Help. This is episode 1, Finding Rate Laws from Experimental Data. Rate laws help us understand how the concentration changes a reaction rate. They look something like what is shown below. K is the rate constant. This takes into account the nature of the reactants, the presence of a catalyst, and the temperature. The A and B brackets are the initial concentrations of reactants in the chemical reaction. Finally, X and Y are the orders of the reactants. Take a look at these 3 rate laws. Each is the same except that the power of the concentration is different. Note that in these cases we assume only one reactant. In this rate law, the concentration of reactant A is raised to the 0th power, which simplifies rule 1. This is called a zero-order reaction. What does this mean? It means that the rate is independent of the concentration and is not affected by it. In this rate law, the concentration of reactant A is raised to the 1st power. This is called a first-order reaction. What does this mean? It means that as the concentration of A increases, the rate of reaction also will increase. Finally, in this rate law, the concentration of reactant A is raised to the 2nd power. This is called a second-order reaction. What does this tell us? It means that as concentration increases, the rate will grow even faster than that increase, the square of the concentration to be exact. So let's practice. In this example, we must look at how the rate changes with the concentration to find the rate law. There's our rate law without any of the reactant orders. And we see that in reactions 2 and 3, since the NO2 is conserved, we can calculate that the initial concentration of NH4 doubles and the rate doubles with it. So we can set 2 to the x power equal to 2 and solve for x equals 1. In reactions 1 and 2, since the NH4 is conserved in those, we can look at how the NO2 changes with the rate. We see that the initial concentration of NO2 doubles as the rate doubles, so 2 to the y equals 2, and y also equals 1. Now that we have both our reactant orders and we have our rate law, we can put those reactant orders in. And since they're just ones, we really don't have to write anything, so it'd be rate equals K times their concentrations. Thank you for watching. If you have any questions, leave them in the comment below. And subscribe, ring the bell, whatever you do.